All right, hello people watching this video. This is for 3E, graphs of polynomial functions. There are actually no examples on the front page. It's just all information. So here we go, okay? This is all stuff that you probably already do know, or maybe have heard before, or it just kind of makes sense, okay? We talked about what makes a function a polynomial function, okay? So it has to be like linear, quadratic, quartic, quintic, all that good stuff, which means it has curves, which means it is continuous, which means he doesn't have any jumps or skips or holes or sharp corners or anything like that. These things don't happen in a polynomial function. So this is kind of like a vertical asymptote over here. So these are non-polynomial functions, not good, okay? Polynomials only have curves or are straight lines, okay? No jumps, skips, holes, vertical asymptotes, no, nothing like that, okay? No sharp corners, no absolute value looking things, anything like that. That is not a polynomial function, okay? So polynomials, we've talked about this just on your homework assignment just now. If it is an odd degree, okay, what's an odd degree?
Means it's opposite going direction.
Like x to the first, or x to the third, or x to the fifth, or x to the seventh. That means it's going to go opposite directions, right? So your end behavior, one will start down, one will start up, okay? If it is negative and odd, meaning like a negative x to the third power, it's going to go like this. So you might want to add that to the list, okay? So still going opposite directions, but going downhill from left to right. Do we know that already? Sure. Do we know that already? He's going downhill, okay? Even functions, which would be like x squared and x to the fourth and x to the sixth and blah, 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 continuing on. They're going to go the same direction. So either up and up or down and down. When is it down and down?
When it's negative.
When it's negative, like negative x squared. That's what this guy is, okay? Down and down. This would be a positive x squared, okay? Up and up, all right? We know that. The end behavior is determined by whether it's positive or negative and by the degree, right? If it's odd, it goes opposite. If it's even, it's the same direction, okay? All right, end behavior of polynomial functions. We just discussed that, odd and even. Okay, now, intercepts. Let's talk about intercepts. We have two different types of intercepts, and they are x-intercepts, and we have y-intercepts, okay? Now, let's talk about x-intercepts. The number of x-intercepts is determined by the degree, kind of. Okay? The number of x-intercepts.
Possible.
This is your y-intercept.
Most.
That's all you know. You have to break it down.
Number of zeros
I've already done this.
equals the degree. Okay? The degree tells me the highest number of intercepts I could have, right? The degree tells me the highest number of intercepts I could have. So we've talked about that before. Like how many zeros should you have? You should have 4 if it's x to the fourth, okay? How many y-intercepts will a function have?
One. No.
Only one ever.
I mean, what if it's not a function though?
We're only talking about polynomial functions. It has to be a function, okay? So if it's a polynomial function, it can only have one y-intercept. Why can't it have 2?
Only goes left and right. 'Cause then it would be a function.
Like what happens if it looks like that?
Not a function.
And it has 2 y-intercepts. This is not a function, okay? So you can have a ton of x-intercepts depending on the degree. You gotta listen. Ton of x-intercepts depending on the degree, but you can only ever have one y-intercept in order for it to be a function. Okay? Otherwise it will look like this and it will not be a function. Okay? Alright, this you probably didn't know. Calc kids, you know this.
Hold on.
What?
You could have no y-intercept there. No, you have. Never mind.
If it's a function, it has to have a y-intercept at some point. Yep. Okay, alright, this is something that you don't know, so everybody listen up. Calc kids, you know this probably, or you should.
Don't touch me.
Okay? Multiplicity. Have we talked about the word multiplicity before? Okay, so let's say I have a polynomial function. I'm going to do a little example down here. Chase, are you listening?
No.
I'm going to do an example down here. I have a polynomial function that is x to the third and then blah, 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 blah after it, right?
Yep.
And what happens to that x to the third power is it breaks down into x, let's say, plus 2 times x plus 2 times x minus 3, let's say. Okay? That's how that x to the third power function breaks down. So if I do all of the breaking down stuff, I get that as a thing. Okay? Are you ready? You have to listen to this. This tells you a whole bunch of stuff about the graph, okay? If I set these equal to 0, that means that x equals -2. It's going to cross at -2, right? X equals -2. It's going to cross at -2. We just said that, right? X equals 3. It's going to cross at 3, right? How many places is it actually touching how many zeros do I actually have? 2, because this is the same number. And what this means is that it has multiplicity, there's that word, multiplicity of 2, which means it shows up twice as an answer. What is the multiplicity of this answer?
1.
He shows up as an answer only once. Okay? All right? Does that make sense? Shows up as an answer twice, shows up as an answer once. Can you have a multiplicity of 3?
Yes.
Sure, if you have like x plus 2, x plus 2, x plus 2. -2 is a multiplicity of 3, right?
Can
Okay.
I have multiplicity 4?
Can you have a multiplicity of 4? You betcha.
I-
Sure, you sure can. Okay? So now, here's the deal. Write this down. If it has an odd multiplicity, write this down. If it has an odd numbered multiplicity, like this one, this has an odd multiplicity. The graph will cross at that 0. Okay? So it will cross at that 0. Okay? What do I mean by cross?
It's going to switch from the negative to the positive and positive.
Right. So at 3, my zeros are at 1, 2, 3, and at -2, right? So at 3, he's going to cross. He's going to do something like this, right? Okay, he's going to cross over the graph. If it has an even numbered multiplicity,
So I'm going to touch.
I feel like I spelled that wrong. Multiplicity. If it has an even numbered multiplicity, the graph only touches. The graph will only touch at that 0. Okay, so how can I make it only touch at -2?
Add another x plus 2.
Like I do this, right?
Oh.
This is touching. This is what it looks like to touch. This is what it looks like to cross. Does that make sense?
Yeah.
Touch, cross. That tells you what the graph looks like, okay? If it's an even number multiplicity, like if it shows up as an answer twice or shows up as an answer 4 times, okay? It's going to touch and not cross. If it only shows up as an answer once, or if it shows up as an answer 3 times, or 7 times, or 51 times, it's going to touch, or it's going to cross through at that point. Does that make sense?
Is that even a thing?
Yeah. What?
How can a line cross through the same point 51 times?
If it's a circle, duh.
What?
It's not crossing through 51 times. It just tells you, like, the fact that the multiplicity is 51. It would be like an x to the 51st power, but it would only cross through at that other place.
Strange.
Okay? All right, good? All right, let's use that on this side. All right, multiplicity of zeros. They have this function. We're on the top of the second page. Everybody go to the top of the second page. Okay? They have this guy broken down for us. If I would FOIL that all back out again, we're not going to, but if I did, what would the degree of that function be? It would be x to the something. What would it be?
No. One,
X to the what power?
6, yes.
That's what I just said.
This is a square, right? I'm foiling that out, okay? Then I have another one here, and then I have 3 of them here. So that would be 6 total, x to the 6th power. This is a 6th degree function, yeah? Okay, now, when it says x plus 1 squared, that just means x plus 1 times x plus 1. And then I have an x minus 2, and then I have 3 of the x minus 3s. That's what that means, right? X minus 3, x minus 3, x minus 3, right? Like, think about that. That's what that means in your head. You don't necessarily have to write that out, but that's what that means, right? So these two, if I set them equal to 0, x will be equal to -1, yeah? Okay, with a multiplicity of 2, because it shows up as an answer twice, right? So at -1, is it going to touch or is it going to cross? At -1, is it going to touch or cross?
It's gonna touch.
It's going to just touch. It's not going to cross at -1. Touch. It's going to touch and it's not going to cross. Okay? All right. If I set x minus 2 equal to 0, that means x equals 2 is my second 0. Is it going to touch? Oh, it's the multiplicity of that one. 1. Is it going to touch or is it going to cross? At 2. It's going to cross because an odd multiplicity. It's going to cross there. Okay? here I have these, and these are all the same, and x will be equal to 3 with a multiplicity of 3. Is it going to touch or is it going to cross? Cross. So I only have, out of the 6, I only have 3 zeros. Now, one other thing, I always tell my calc kids, I told them this, your multiplicities, 2 and 1 and 3, those should add up to be your degree. So if this has a multiplicity of 2, 1, and 3, if I add those up together, that should be 6 total zeros, right? It just so happens that some of those zeros are repeated. Does that make sense? Yeah. Are you guys paying attention?
I am doing my
I
own.
have everything else written down.
All right, good. Let's go down to example 2. Complete the graph of the polynomial. Find a complete graph of this. Okay, here's what this means when it says find a complete graph. Tell me the range that you have to have your x's set to and your y's set to so that I can see a complete graph of it. Because if we do the standard viewing window, negative 10 to 10, you might not see all of the pieces of that graph, right? This is an x to the 4th power, all right? If it's x to the 4th power, we know that he has to look like what? He looks like a little W. Now, he might not have like that hump in the middle. He might be like flatter in the middle or something like that, but we know that he's going to go up and up, right? Up and up, up and up. Or does he go down and down? No, because he's not negative. He's x to the 4th. So I know that I am looking at an entire graph of it if he goes up and up, right? Okay? So what we're going to do is get your calculator out. Graph this function right here on your graphing calculator. Okay, let's find what the window needs to look like. Okay?
And just use the fancy.
Use your graphing calculator. What? I know, we'll do that later on. Okay, but I want you to graph the first one. You graph the first one. You graph the first one. And start with a viewing window of negative 10 to 10. Start with a viewing window negative 10 to 10. Because you got to start somewhere, right? So plug that in. Start with a viewing window negative 10 to 10, and we'll see if we can see the whole graph at that point.
We won't. The y-intercept is negative 80.
Oh, you can't even see like half the graph.
Okay. All right, you guys can tell from here. Negative 10 to 10 works for the x-axis, right?
Yeah, I guess.
X-axis it works, but the y-axis you got to go all the way down, right? Okay, so let's figure out the y's. The x's have to live in between, and the y's have to live in between. I'll put equal to's on here. Okay. You should look something like this, right? If you use negative 10 to 10 on the x and negative 100 to positive 100 on the y, okay, that would work. Now, let's say I want to pinch him in closer. I have a lot of wasted space over here, right? You see that wasted space? If I want to pinch him in, I could go from like here to like here, okay? So I could pinch him in smaller and get a better view of the graph. What could I go from?
Say 5. 4. 4 would be good.
4 on the right?
Yeah.
Okay, what about on the left?
7.
Negative 7, okay? So we could go from negative 7 to 4, and that would pinch him in a little bit closer, right? Okay? Now, do we have to go all the way down to 100?
Well, pretty close.
I would say yes, maybe. So the y coordinates need to go all the way down to 100. Do we need to go all the way up to 100?
No.
The last exciting thing that happens in this graph, like occurs like right here and below, right? These really aren't doing anything for me, those little tails, because I already know he's going up and up, right? So after this little hump that occurs right here, I could cut him off there. Does that make sense? Okay? So if I cut him off, let's see. Cut him off right there. What could I cut him off at? Could I cut him off at 50? On the top?
60.
Like 50 across the top? 60 maybe? Should we do 60 across the top?
I don't know.
Okay, so let's go negative 100 to 60 on the y-axis, all right? To pinch him in a little bit smaller. So our range, our viewing window would look like this
Yeah, that works.
instead, right? And I would be zoomed in just a little bit better and not have as much wasted space, okay? So when they say find a complete graph, they're asking for the viewing window that you're going to use. You might have pinched him in different than we would, right? They did negative 10 to 10 and negative 100 to 100. I'm saying I would go maybe even a little bit pinched in more than that to see it a little bit closer and not have as much wasted space, okay? So you might have something different than somebody else, but as long as it works, okay? All right, so let's talk about this one. You don't necessarily have to graph this one because they have the graph, right? Find a complete graph of this guy. This is an x to the third power. I can see the full x to the third power. They're going negative 6 to 6 and negative 6 to 6. Could we pinch him in smaller?
Yeah.
Probably. Like there's a lot of wasted space over here. Holy cow. Okay, if we do our x's, okay, what are our x's going to go from?
Could do like
-2 to 3.
negative 2 to 3.
Negative 2 to 3, you want to go?
Yeah.
That sounds good. Okay, the y's. Should I go negative 6 to 6 or should I go something else?
You go like negative.
The exciting part of my graph is happening here, right? Like that's where the point of inflection is. So I feel like I could cut like this bottom off at least, maybe.
Like
And maybe even the top off like by
negative
1. Negative 1 to what?
4.
4 or 5?
4.
4, sure. Negative 1 to 4. So negative 1 is here, 4 is up here. We can pinch him in that far. That would give me just as much of a picture of the graph as what we have now, right? Okay, I don't need all that excess side information. That would zoom me in a little bit further, okay? So, I mean, this is debatable. You can go, you could have gone negative 1 to 5 instead. But as long as you have a complete graph and you can see all of the important features of the graph, all right? Determine if the graph shown in this figure is a complete graph of this thing. What does this thing look like? What parent function?
W.
He looks like a W. He looks like an x to the fourth power. What is he actually?
I'm next to the 5th.
X to the fifth power. So am I looking at a complete graph of the thing? No, because he has to go. X to the fourth goes in the same direction, which is what it looks like here. But x to the fifth should not go in the same direction. Now, here's the question. So that we can tell this, it says determine whether the graph is a complete graph.
It's not.
We're going to say no because should he go down again on the right side? So should he do this again? Right? To go that way
No, on the left
and
side.
go like this?
The left side.
Or should he go the other way?
The other way.
He should go this way. So be down here and then be up here
Yeah.
because that would be positive, right? He is positive x to the fifth power. Okay, so he should go over there. So no, because he has another what? 0 to the left of negative 10, right? He has to have a 0 to the left of negative 10. Maybe it's all the way out at negative 100. I have no idea, but I know it's outside of negative 10 because that's what the range they give me, right? I know that has to be a thing, okay? Good?
Great.
All right, there you go. That was the notes for 4-3. Lots of graphing and like matching and using your like all that good stuff, okay? When it says find a complete graph, all you're doing is giving me the range of the viewing window, okay? Like this is not a hard section. I feel like this is way easier than yesterday. Okay? It's all matching them. It's a lot easier than 4-2, that's for sure. Like the last two questions, they baby step you through it. Is this even or odd? Is the leading coefficient positive or negative? What are the zeros? Locate them for me. Does that make sense? Okay, so this shouldn't be too bad. Get a start on this. Monday, you will be gone for the majority of the class period. I don't know if like one act people, probably won't be here at all because you'll be performing and cleaning up stuff. But Tuesday we'll play turkey trivia, so we will turn this in probably on like the following Monday after Thanksgiving break, okay?
Nice.
But I would use your time to work on it because it's gonna leave your brain as soon as Thanksgiving break hits. You're not gonna remember this, okay? So there is that, yeah. All right, you can do like a good majority of this homework assignment now. You have like 15 minutes. Okay. Goodbye, people watching this video.